In this video, I want to go over problem number 1 in the exercises section of page 107. And they give you a definition: f prime of a is equal to the limit as h approaches infinity of f of a plus h minus f of a over h. And problem number 1 is having you apply that using f of x equals 1 over x and a equals 2. So if a equals 2, we're just going to rewrite this definition and replace every a value with a 2, or in other words, substitute 2 in for a. So we have something that looks like this. And now you have to determine what f of 2 plus h and f of 2 is using f of x equals 1 over x. So this is where we use, where we'll be doing the side note. And if we directly substitute 2 plus h for every x value in my function, 1 over x becomes 1 over 2 plus h. And if we directly substitute a 2 for every x value in my function, 1 over x becomes 1 over 2. So we can now go ahead and replace f of 2 plus h with 1 over 2 plus h and f of 2 with a 1/2. And this shouldn't be too difficult. We now have f prime of 2 is equal to the limit of 1 over 2 plus h minus 1/2 over h as h approaches infinity. And if we do our direct substitution, we see that in the numerator we have 1 over 2 plus 0. So 1/2 minus 1/2 is 0 over 0. This will not work, so we need to do some algebra, some simplifying. So think of what kind of simplifying, or how can you do some simplifying to solve this problem. And if you simply get common denominators, so with the 1 over 2 plus h, you get common denominators. That'll help simplify this. So now we have something that looks like this. Very important, don't forget to put parentheses around 2 plus h, because we are going to have to distribute that negative. And when we distribute that negative, notice that the 2 minus 2 will simplify in the numerator. It'll become 0, it'll cancel out. And then that positive h becomes a negative h. And if you remember, that h in the denominator is h over 1. So when you divide negative h over 2 times 2 plus h divided by h over 1, you're multiplying this numerator. You're multiplying it by the reciprocal of this denominator, and the h's will simplify. So we're looking at the limit as h approaches 0 of negative 1 over 2 times 2 plus h, and we are ready to do the direct substitution. So substitute 0 for h, and we are left with the final answer of f prime of 2 is equal to negative 1/4. And that is the final answer.